All right, so today we will be talking about structural design basics, and this will be our first webinar in a webinar series for structural design basics. And then if I can just ask everybody to mute themselves on Zoom, just so we don't have any feedback. Then of course, if you have any questions, we'll ask you to unmute. If you're unfamiliar with how to unmute, I believe on the next slide or the one after that, we'll have the Zoom pane. So like I mentioned, we're going to be talking about how to read structural drawings today. So a pretty high level one, but a great first one before we get into this webinar series of structural design basics. Hey, both Dennis's, thanks for sending a hello through. Great to see you guys. So I know we have a lot of people here who have either trialed ClearCalcs in the past, maybe you're currently trialing it, maybe you're a current customer, or maybe you kind of had never heard of us before you saw us on LinkedIn or Facebook or wherever you signed up for this webinar. So very quick about ClearCalcs if you're unfamiliar with ClearCalcs. So we are a cloud-based structural engineering platform, of course, helping you to be more accurate using our FEA analysis. We want to eliminate wasted time for you. Of course, that's the end all be all, using our features such as load linking. So you could dynamically link your loads down its load path, using our member selector. So you can quickly see, what's passing, what's failing, and how close you want to get to that 100 utilization. And then also using our swap material. So letting you design wood, steel, cold form steel, concrete, with the click of a button without having to input any new information or start from scratch. And then, like I mentioned, we are cloud-based. So whether you're at home, at the office, at a coffee shop, on your laptop, tablet, phone, a friend's computer, whatever, you can access your projects. All right, and then next, one sec. I'm going to send a quick message here. Okay, so meet the presenters. So of course we have me, Connor Consman. I'm our Director of Customer Success. I'm here to make sure you're successful in ClearCalcs. I think I might have lost screen sharing here. All right.
You might just need to do that again, Connor, sorry.
Yeah, sorry about that, guys. Technical difficulties, no problem. Let me share. Hey, Addie, it's saying that it's disabled by the host right now.
Let me just make that.
Sorry about this, everybody. All right, all set. Thank you, Addie.
Right.
Addie's always behind the things, making things happen, which is exactly what I wrote for her, as Addie as the other person who's behind the scenes on today's webinar. She's here to make sure all webinars and other help content is effectively planned, whether it's blogs or worked examples, anything like that. Addie's the one that's pushing to make sure those go through. So every piece of help content you see, thank Addie. All right. And then how to ask questions here. It looks like a lot of you guys already figured this out with how to use the chat, but use the chat button there. You can send through any comments, suggestions. You could tell me how many times I've messed up already in the webinar, and we'll be happy to take that constructive criticism. But we do have a 15-minute Q&A at the end of the content that I'm talking through. So send those through, we'll make sure to get to them. All right. So what will we be talking about today? Hopefully most of you guys know since you signed up for this, but we've been getting a lot of questions from people who have been coming on these webinars in the past and attending them, that it would be very helpful to start doing some examples and content on real world engineering projects. So first, I want to shout out a guy named Jason Michael Neal, who's a ClearCalcs user. After all this feedback we were getting and suggestions, I had asked Jason if he could provide us with some real world examples. and he was gracious enough to do so. He sent a real world example of a home that he designed in Taos, New Mexico, which first of all, I'm extremely jealous of the person who bought that home because that sounds incredible. But thank you to Jason. And then he also got some sweet ClearCalcs perks out of that. And then thanks for sending that question through. Yeah, if everybody be able to just mute, if everybody's muted and it ends up being me, I'll switch headphones to make sure we're all set. But today, getting back to the presentation, we'll be looking at a high-level look at where to locate important structural information or structural information in the structural drawings. So very high level, but we're going to use this webinar as webinar 1 to go in the coming months to start to design each component of that building. And when I say important design information, I'm talking about the design loads. So roof, snow, wind, seismic, dead, live, all that fun stuff. What are we designing to and where to find that? Installation instructions. So for the builder or contractor, whoever's actually constructing the home, connections and all that fun stuff. Also specified materials. So here we're talking about the member schedules, where to locate those, where to see the actual beam or column or footing or shear wall that the schedule is referring to. And also acceptable alternatives. We're always not gonna, if the engineer specifies something that doesn't 100% guarantee that's what we're gonna use. That's where the ClearCalcs member selector would come in handy. And then we're also gonna look at the actual member geometry and boundary conditions. So finding and locating the beam, say, and where are the supports and all that fun stuff, and how to transfer that into our hand calcs, our spreadsheet calcs, our structural engineering software like ClearCalcs. And then I've said this 1,000 times already, but this will set the stage for future webinars. So I've been talking a lot today already. So to start, I figured a good starting point for navigating structural drawings is looking at what is the difference between architectural and structural drawings. So I Googled it, what are architectural, blah, 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 what are structural, and I seem to get zero information. If you look at Wikipedia via a quick Google search, architectural drawing definition is basically telling me architectural drawings are architectural drawings, and same with structural. Structural drawings are what they are. So I figured this would be a good case where a picture is worth 1,000 words. So I grabbed this example. This isn't going to be the example we go through today, online as well, where we have a screenshot of the structural drawings or the architectural drawings here, and then also the structural drawings here. So you can see at the bottom where there's a lot of different rooms, why this is the architectural drawing. It's showing us where the cabinets are located, the closets. It's showing us where the doors are located and which way they swing open. Also the plumbing fixtures, so we're seeing the toilets and sinks, stuff like that in the bathroom. So basically the architectural drawing is telling us, how this is gonna look. Where are we gonna place certain fixtures within the building? And then of course, the architectural drawings, other drawings, not this one, would also have, where are we framing? Where's the wood framing? Stuff like that. Whereas this same building, the structural drawings you see are a lot more like messy, just because we don't have to put in the fixtures themselves on how it's actually going to look. You can see in here, it's giving the maybe concrete around the elevator pits, the concrete walls around the bathrooms and the kitchenette, I assume they had in there, around the stairwells as well. So the structural drawing is basically the bones here. It's telling us where the architectural is telling us, here's how it's going to look. Structural is like, here's how we're going to make that work. Here's how we're going to put the walls up and all that fun stuff. So quick examples there. But now I just want to really quickly show you guys the actual drawings that Jason was willing to give us here. So right here, we're looking at, it's a relatively small drawing set, which I think is perfect for this webinar. We're seeing, the general notes, the schedules, actually getting into the foundation plan, the framing plans, and then all the way into some truss details and some regular details here. So what that brings me to, if I click on the right tab, is the page nomenclature. So that's going to be the number one that we're going to start with on how to read structural drawings. So I've got this article here that I found online. I thought it was an incredible resource. I figured, why reinvent the wheel? So shout out structural details here. If I scroll down, the first components of the number or the page nomenclature, which is actually going to be the number on each page, how we're going to read, how we're going to navigate, is this AA, so discipline generator. And I'll scroll down here to this table they had. Really, that's just the number one letter or variable or designation, whatever you want to say, of your page number. In our case, everybody on this call, I assume, more likely than not, their drawings they're making or the drawings they're receiving have S or A, the structural or architectural, of course, if you're using ClearCalcs. But outside of that, we're also going to have other letters. Like I used to work as a mechanical design engineer for a consulting firm, and we would always be M. Or you got electrical E, you got plumbing P, fire protection F or FP. So that's always going to be the first letter of your drawings or the name of that sheet. Now, in some cases, not all cases, especially in our drawings, we just have the one S today, but you might have a second letter. We could see here some examples in this table right here on this website. We could have a D, D for demolition. I feel like I'm like an elementary school teacher saying that, D for demolition. But we could also have, in my case, I used to have sheets all the time that said MP or mechanical piping. So if I had gas or refrigerant or something going through. So in our cases, we might have SD, AD, or whatever other second designator we want to use. Again, they're not always going to be in there, but if you want to make your drawings as organized as possible, then I'd encourage you to add that second designation if it pertains to your project. So finally here, or not finally, second to last, I should say, is the sheet type. So we've already got those first two letters talked about. We've got the S and the A most likely as the first one, that depends the second letter pertains to us. But then the sheet type is looking more at, is this the actual floor plans? Is it elevations? Is it the details? Is it my schedules? The one thing I will say in this case is this table right here is definitely not an end all be all. I'm sure half or more of the people on this call have different designations there, and maybe they call their details 4 or their schedules 2. But this is just an example of how we would go through on our sheet index to tell whoever has the project, whether it's a permit reviewer or somebody else, how to navigate our drawings and what they should expect to see. Lastly, this one's the finally, is just a sequence number. So this one's relatively self-explanatory. It's, 01 is the first page within that certain designation. So for example, they give some great options here. In my case, I would have had mechanical piping 501. So per their designations here, I would have MP's mechanical piping, 5 is that it's the details, and 01 is just it's the first page of the details. And we can go back to our example here, where, like I mentioned, that we don't always have to have that second letter. So we just have S 0.1 to 0.4, S0 1 to 5, and then S 3.1 to 3.4. And that's just telling us we could see within the sheet index, the general notes, the actual plans, and then the details themselves. So the next thing here, I guess, is where do we find this sheet index if we've been given drawings, or even if we're making the drawings? Where's the best place to put it? And there it would be the general structural notes or the very first pages. So let's jump back into our drawings and actually look at them together. Scroll all the way to the top here. We can zoom in on the bottom left. You can see it kind of stands out. We've got our sheet index there. So especially if we have an engineer, if we're an architect and we have to have an engineer reviewing our drawings, that's where they know to look. If a permit reviewer is looking at them, that's where they know to look. And then these general structural notes in general are the most probably important part of your drawings, because it's telling everybody what code you designed to, what loads you used, what soil PSF you should be assuming, what you need to be doing for connections, what you need to be doing for wood, metals, concrete, masonry, all that fun stuff. I will say, in my experience as a consulting engineer, I saw a lot of people at my company, maybe you guys have too, maybe not, I'll speak for myself, just copy paste a lot of these. More often than not, I saw a lot of the general notes copy pasted from past jobs. I highly, highly, highly encourage everybody, even if you are copy pasting to save time, we're always up against the gun, so we got to do what we got to do. And then I'm just seeing this question, providing the web address for that page. Yes, we will send that through. Everybody will get access to the presentation as well. And I linked it in that slide. Great question. But going back to, if you are copy pasting, just make sure you're reading through line by line and making sure it actually pertains to your project. I've had a couple of times at my past job where there were comments in there that said this was allowed when it shouldn't have been, or that wasn't allowed when it should have been. So whether you're on the side where you're making the drawings, or even if you're on the side where you're receiving the drawings, make sure the receiver is reading through every one of these as well, because this is it is very important information for the contract that you guys are in, and it'll be what the engineer brings on site when they're doing their on-site visits to make sure everything's going to plan. All right, let's go to this next page while I drink some water. So next, what we got here is the design loads that I've mentioned a couple times already and where to find them. So I took this screenshot from the drawings just to minimize back and forth, and so you guys can see it when you actually receive the recording and the presentation. We can see the design loads were two. It's kind of hard to see. Maybe I'll just go into the drawings themselves. This engineer was telling us that these drawings were per IBC 2015 with New Mexico revisions. So New Mexico's in there, of course, because that's where this building is. You need to double check that your local code, you're designing to that. Unless you're in New Mexico, you're probably not doing that. And we can see here clear as day that this engineer has told us, all right, our residential live loads 40 PSF, our dead loads for roof and floor happen to be 20. Here's our roof snow load. Here's our wind design data. Here's our seismic design data. So of course, when we're making the drawings, we need to make it clear to either the reviewer or the probably permit reviewer as well, what we used as loads for our designs. So that's where to find them when you receive the drawings. But where do you find those loads if you're the one creating the drawings? Let's just jump back in to our Google Chrome one here. So I took this information. This is just a screenshot from the Taos, New Mexico building permit information. I'm sure most of you guys know this, but if you don't, all I did to find the information for the loading here was I searched Taos County, New Mexico building permit information. Easy as that. It was the first pop-up on Google. And then I got all this info that was used in the code or used in the drawings. If for some reason you guys are having a hard time finding this information, just reach out to your permit reviewer. That'll just minimize the back and forth of them reviewing your drawings. So just give them a call on the phone if you can't find it online. All right, so we've gone through page nomenclature and how to navigate that. We've gone through the I'm forgetting already, the general structural notes, the design loads themselves. And then now let's talk about these grid lines that we're seeing on these drawings. Of course, these aren't just for structural, these are on all drawings. But I took these screenshots so we can come back to this and minimize back and forth later. But these grid lines are just the horizontal and vertical, zoom in a bit, lines that are telling you no matter what sheet you're on within the drawings, no matter what floor or level you're on within the structure itself, that's where we can line up the grid lines. And we know that top down, we're going to be able to track, and we know that those line up in real life. Now, the reason I think those are especially important using something like ClearCalcs is so we can use that load linking feature that I mentioned before as effectively as we can. So I'll come back into our drawings here, or our presentation. And we can see, so this screenshot that I took from the drawings on the left is above this screenshot on the right. So left is just laying right above the right-hand side screenshot. And we could use these grid lines to actually line up exactly where the building itself and the levels line up, of course. So the reason I brought up load linking is if we can see under grid line E, we've got this ridge beam that's resting on two 10 by 10 posts. And we can see here in the floor below, of course, we just see those posts. The ridge line is above and the posts are in that same location on the right. And you can imagine with also the foundation plan, we would likely have a spread footing or some type of footing or foundation under these posts, and we would just track those down. Now, very quick look in ClearCalcs of just setting up that load linking. I assumed this ridge beam started at this post and went 15 feet out to the end. And I'm just going to say this second post is 5 feet in. So if we jump in here to, whoops, trying to open up ClearCalcs here. It's just hiding it. I'll just go to clearcalcs.com. We'll log in. So if we zoom in here a bit, just because I know it's probably, there we go. So what I did here, I just created a group called Ridge Beam Load Link. And then I've got my ridge beam itself with that overhang, that 5 foot overhang from our drawings. So I'll just give you guys another look at what that looks like. So I've got 10 feet right here and 5 feet right here. Too many things open. And then what I did was just come down and created 2 different columns here. And I could see I linked that ridge beam 1, support 1 down. So you could imagine by following our grid lines there and making sure we're getting, what's on top of what and correctly tracking that load path, we can use that tool in ClearCalcs to expedite our process. All right. So next, we'll just look at locating the actual structural members and their associated member schedules. So when I was practicing this webinar with myself this morning and last night, I actually found it was best to do these 2 together, these 2 slides. So basically I just have here, we're going to take a high level look at finding and locating the joists, headers, rafters, footers, stuff like that within the drawings themselves. And then going to locate the member schedules as well. That's going to tell us, what size is that beam, what manufacturer, what species can I use? And so we'll look at those together now in the drawings themselves. All right. So first, let's use our knowledge from the page nomenclature, the first slide that we went through, to look at the sheet index to be like, all right, where are these structural schedules? Because we might have a massive drawing set and we don't want to have to flip through all of them. So at S0.3, we know that sheet is the structural schedules. So let's zoom out here. We're at 0.1, 2, and 3. So here's where we can zoom in and see, whether it's the diaphragm, shear wall, SIP panel, beams, headers, joists, all that fun stuff. This page is going to tell us the size and what's acceptable to use, the species, sorry. So let's start with just locating, one of these beams. I know this is probably review for most of you guys, so we'll just look at one of them. But let's say we want to find the beam on the drawings that has this hexagonal 1 symbol, because we then know that that's a 10 by 10 beam. And we know, whoops, scroll back up here. We know even further, if this will cooperate, that all timber beam sizes have been sized to Douglas fir number 2. So finally, we can see it here. All timber beams have been sized to Doug fir number 2. But let's find this one first. We're looking for that hexagonal 1. I already know where it's at, so I'll just go straight there for the sake of time, of course. So we'll zoom in. We see this hexagonal 1 on these drawings. So we know that this beam right here is a 10 by 10 Doug fir number 2, or at least it was designed per 10 by 10 Doug fir number 2. And this engineer has been nice enough to actually include the schedule itself on the same page. So we could zoom in again and confirm here, wood beam schedule number 1 is a 10 by 10. Now this is where I'd want to just quickly point out to make sure that everybody that's currently using ClearCalcs takes advantage of this, this feature. If we come back in here to our member selector. So basically I just created a group called member selector example, and I put 1 wood beam 1 in here. So let's imagine that this engineer, he did use ClearCalcs for this, but he put in all the correct information, the geometry, and then he came into this select button, which is what is called our member selector. He had it at Doug fir, and then grade number 2. So here, obviously I didn't change the loads or the length, the supports, anything like that. But I'm out here and I could start to change the species. If I get rid of that, then that just made this list even bigger. Under this, we'll see every Doug fir. We can even go through and select a certain manufacturer. Maybe we have a good relationship with the local supplier and they have a good relationship with a certain manufacturer. And we could then select the one that has at least all yellow, so it passes. So if anybody has any questions on that or the load linking that I ran through very quick, let us know. We'll be sure to send out help content. We did a webinar on the load linking, so we're happy to send that information through. All right, so let's head back into our actual presentation. So we just located the member schedules themselves using our new knowledge or reviewed knowledge of the page nomenclature, and then actually finding it and finding what we can use and what we can't use on our drawing or construction. And then finally here, we're going to look at the details. So I took some screenshots and put them in the slide. So we don't have to do much back and forth, but I just want to show you guys as a review or as new knowledge, where to locate the details symbol and how to read that, how to find the actual detail that we're looking at. So let's come into these drawings. And the detail that I had screenshotted in our drawings was this one right here. So you could see we've got an outdoor deck or deck joist, which by the way, this deck, if you look at that, that looks beautiful. Can't imagine the mountain views. Let's zoom in here. And then we've got number 5 is the beam. And then we see this detail symbol. And what this is telling us is that we want to go to page S3.3 and look for detail 7. So on the bottom here, it's going to tell us the page to go to. And at the top, it's going to tell us the detail we want to go to. So let's go to S3.3. All right, got it finally. And then we would zoom in here to detail 7. So that's just to show you guys where I located these screenshots that are in the presentation. So if we come back in here, basically what it's telling us is at this location, and it makes sense because we have a deck joist coming onto a deck beam. It's telling us the joist per plan. So again, using our newly found knowledge of reading the member schedules, we know that J2 is a 2x10 at 16 inch on center with this Simpson hanger. And then we know the beam per plan, since it's number 5, is a big old 10x18 beam under those deck joists. So that's how we would go from locating the symbol for a detail in the floor plan or the drawings, and then navigating to where it is under the details pages. And then of course, using that knowledge of the member schedule to determine actually what that is. So that's about it from the reading structural drawing standpoint. I do just want to kind of highlight one thing that's upcoming in ClearCalcs. Some of you might have heard this from me on some demos, but this is just a standards preview. So we're doing some exciting things with code and standards body. Some of them you guys might have heard of, IBC, IRC, ACI, AISI, ASCE, and so on. Currently, I hope you guys know that you could use what we call our help accordion feature, where at any one of these inputs, you could just click the letters. It's going to expand to give you additional information. In a lot of cases, it's going to give you standards and codes references. What our development team is working on right now, I'm showing you guys what's active in Australia, because Standards Australia and us just made an agreement, which is very exciting. But they're making this button of the standard. So imagine this will say IBC XYZ or ACI XYZ, a dynamic button where you click that, and then it's going to bring in line that code itself, the exact part of the code that this input refers to. We're finding, or we're seeing that this is going to save people money, one, because you're not going to have to update your code books, standards books for $300 each every time you got to change them. You're not going to have to open up a book in general. You're not going to have to go on another page or tab. It's going to come in line with ClearCalcs, and then not to mention the learning for those junior engineers who are just kind of working on the code for the first time. If you guys have any questions or comments or anything about that, please let us know in the comments. I would be happy to set up a separate demo session if you're interested, answer any questions you guys have on this feature in general. We're always happy to get input as well, as hopefully you guys know. And then that is it for today. So I know I haven't seen many questions come through, but if anybody has any questions, feel free to send a question in the chat, and feel free to unmute yourself as well if you're comfortable.
Connor, I actually have questions for everyone.
Oh, okay, perfect.
Since we're talking about standards, I'm curious to know for all of you designing and then are they creating drawings or receiving drawings? How are you currently accessing codes and standards in your work?
So in like ClearCalcs, how do we have these coming up, or in like as a designer?
As a designer. Yeah.
Oh, okay, great question. So let me go back to this page here. So really what you need to do is, once you know where you're building this building, you just need to find out what county in the state that's in, or in whatever country you're in, just you need to know what building code you guys are just currently designing to. Because for example, here in the US, it may differ greatly depending on what state you're in. I know like California has essentially just its own code that differs a lot just because of the seismic, same with Florida and wind. I used to work in Chicago, so Chicago code was its own animal. But you really just, let's say for example, I can just show you how I found this. I knew this drawing was being done in Taos, New Mexico County building permit info. And then you can see I spelled it wrong and it still came up. So it's just gonna give us a link straight to that building permit information. Like I mentioned before, if you can't find this that easily, just find your local building department or where this is being constructed, find their contact info, and you should be able to give them a ring. Does that answer the question there?
Yeah, and I'm also curious from our participants and how they are currently finding that codes and standards, like whether you need to purchase them or accessing them.
Oh, right. I think I answered getting like the what you're using, but yeah, the actual codes and standards, yeah, you might have to buy the book or get the PDF online. And then Dennis, looks like you got your hand raised.
I got a question. You mentioned you thought, or I think you said those were only available as far as the calcs standards were only in Australia. Are there anything forthcoming for the United States?
Yeah, very sorry. Let me be more clear with how I was saying that. So it's currently close to being finished in Australia, just because we ClearCalcs made an agreement with the body called Standards Australia a while back, but we've just started working on IBC, ACI, AISC, all the fun ones. Great question though. Sorry, I was unclear there. Yeah, so it looks like, yeah, you can get the codes online there. Francisco and Larry mentioned. Benefit when they come into the US is bringing them in line with ClearCalcs. So that way, if you're working on, for example, I'm gonna choose a random thing. If you're looking at the input for like moment utilization for a wood beam, it's gonna bring in that exact moment location where they talk about it in the code and the commentary into ClearCalcs. So yeah, you can, I believe there's some standards, at least I'll say in my communication with many of our users, that they have to pay for to get up to date. But yeah, you could get like the ICC codes. At least I used to be able to when I did the mechanical code. Then, yeah, Dennis, thanks for that question. Any other questions there, Addie?
There's a question from Hadi asking about, is Californian Building Code 2022 is now supported?
Great question.
Then, yeah, how to change the set of calculation to 2022 from 19 all at once, if that's possible.
Oh, okay. Yeah, so once you go into your drawings, that's a great question, I guess too. But you can click on project defaults on the left. And what this is going to do is allow you in the top left to change your design code. So I'll have to confirm with the engineering team with you can see CBC 2022, 2019, and 2016 are all supported. The concrete, I know for a fact they were working on that the past month or so. And most, if not all, of the concrete calculators are up to ACI 318.19. But we still have this concrete not yet supported. So I'll just need to confirm with the team that those actually are done so we could remove that.
I think we are down
Great
to
question.
one calculator for concrete, and we'll send an update to everyone as well when all of that is available.
Thank you, Addie.
Yeah.
Oh, Harris, yes, I'm just seeing your question. We do have a student version. reach out to, I'm just going to type out. So this is our support email. Reach out to that email about the student version, and then that'll come to me and our engineers, but I can handle it. We'll get you set up with that student version. All right, great question there. Addie, any other questions?
I'm not seeing anything else so far.
All right. We'll probably, guys, feel free to send through your questions. We'll probably hang on for another like 3 or so minutes. So that way everybody gets out at the 45 and you guys can grab a coffee or get 15 minutes back in your day. And I guess if no questions come through in the next minute or so, we'll just assume everybody's all golden. Friendly reminder here, let me just come to the last part of this webinar, or last page. Friendly reminder, everybody, we will be sending the recording of the webinar out, and we'd greatly appreciate you guys' feedback. If you guys can give us some constructive criticism on, how we could do this better, these webinars, or some topics we could focus on in the future. We're always open and interested on hearing topics from you guys, so we would really appreciate that. And then yes, stay tuned for the webinar next month, where we use these drawings and we dive in a bit deeper and actually design some stuff. All right. Thank you, Gary. Thanks for the thumbs up. Thank you, Dennis. All right, Addie, I think we're good to shut it off. Guys, use that help@clearcalcs.com if you guys do have questions. We really do field every question, and that's our top priority. So have a great day, guys.
Thank you, everyone.